Okay. Now, you learned how to find the position and also the velocity of the particle when the particle has a rectilinear motion. Now we want to find the acceleration of the particle. To find the acceleration, I just used this character A to show the acceleration. Also, acceleration is the vector, and the unit of the acceleration will be meter per second square or foot per second square. This is the unit of the acceleration. Now, how we can find the acceleration? If a particle moves from point P, at this point, the particle has the velocity of the v in the direction of the motion, and also move from point P to the point P prime, that at this point, it has a velocity of the v prime, and also at this point, time is t, at this point, time is t prime. Now, the acceleration of the particle can be found by finding the difference between the velocity over the delta t. This is the acceleration of the particle. And also, for this one, this acceleration called average acceleration. Or this is v prime minus v divided by delta t. Same as just you learned about the instantaneous velocity. Also, we can find the instantaneous acceleration. How? If delta t approach to the zero or become very, very small, or t prime is approximately equal to t, just we can find the instantaneous acceleration by finding the derivative of velocity with respect to time. This one is called instantaneous acceleration. Also, if you find this A, or this A average, or average acceleration, or this one, as a negative number, or A average, or A instantaneous becomes negative, this is called deceleration. When the deceleration happens, when delta V is negative, or just you feel the kind of reduce of the velocity or reduce of the speed. This is called deceleration. Can you tell me one example? Maybe you experienced the deceleration. Yes, braking of your car. Until the deceleration. My first section of the class, so one of the students just raised his hand. He mentioned that I just experienced the deceleration. I asked him, what was the deceleration experience? He just mentioned that just I hit to the wall. Is this another example? Now, also we found the acceleration and also the velocity, how we can find. Can I move to the next slide? Okay. Now, the summary of what you learned, how to find the position, how to find the velocity, and how to find the acceleration. Just briefly, I want to explain. Here, without just reviewing all of this, kind of might be formula, just you will see in here. Look, S is a position. V is the velocity. A is the acceleration. Now, to find the velocity from the position, you need to take the derivative of the position, this direction. Sorry, I just said that. To find the acceleration from the velocity, you need to find the derivative of the velocity with respect to time to find the acceleration. Okay, now, my question. If I want to find the acceleration from the position, what's the relation between the acceleration and the position? How can I find the acceleration from S? Can somebody tell me? Yes. Yes, second derivative. To find the acceleration from the S, 2 times I need to take the derivative, or the second derivative of the S with respect to time squared. Now, reverse of this one. If I want to find the velocity from the acceleration, what should I do? What? Integral. If I want to find the velocity, if I have the acceleration, I need to just take the integral. Also, if I want to find the velocity position from the velocity, also I need to take the integral of the velocity. This loop help you a lot, just how to find the velocity from position, acceleration from position, or velocity from acceleration, or position from the velocity. Now, I show you some equations, but this is, you learned it before. To find the velocity, and this is this. And also to find the acceleration from velocity, you take the derivative of velocity, and this is this. Now, what is the third equation? The third equation, if I eliminate the time from these 2 equations and relate them together, I can find this equation. In this equation, there is no time. If you can see, this one just include the time, finding the derivative with respect to time. This one is the v derivative of velocity with respect to s. I do not want to just explain how to find those ones. You are not interested based on my previous experiences from my classes. But this equation, I like it. I like how to just find a derivative of those ones. I love mathematics. And for this one, there is no time. It means that if the velocity is given to you as a function of s position, you can use this equation. Okay? Now this is the third equation. Again, just the integration, this is this one. To find the velocity and the position, if I take the integral, I can find the velocity and also position from taking the integral. And here, two more things that I want to mention. V0 and S0. V0 is the initial velocity. S0 is called initial position. These are the velocity at the position at time equal to 0. For example, from this equation, let me see that itemized. Yeah. V is equal to, acceleration is the derivative of velocity with respect to time. If I multiply this by this, a dt equal to dv. If I take the integral on the both sides, at the time 0, the velocity will be v0. At the time t, velocity will be v. Okay, this is this. If you repeat for other equations, you can find similar integrals. Again, I do not want you to just find equations in my exam or in this class, but if you're interested, I like it. But I will provide those equations for the exam. But you have to know S0 and V0. Most of the time, initial position and initial velocity are 0. Most of the time. But for some specific problem that I will solve today, you will see that S0 and V0, they are not always 0. Sometimes they are not 0. And you have to be careful. Any questions? No. Let's solve examples, then you can see how to use them. Problem. This machine is programmed that during the time interval from 0 to 2 seconds, the position of the head, that is this head, is measured from this point. It's a function of the time. S is 4t minus 2t cubed. What is the velocity and the acceleration of the head at the t equal to 1 second? That's one example related to kind of real world examples, mechanical engineering, it's a mining machine they use for the kind of mining of the parts. And now, for this problem, as it is given to you, S is a function of the time. We are looking for to find the velocity and also acceleration at t equal to 1 second. First question, how can I find the velocity? Yes?
Take the derivative of the function of time equation position.
To find the velocity, we need to take the derivative of s with respect to time. What is the derivative of s with respect to time? If you take the derivative, can you tell me the expression that you find from this equation? Yes?
4 minus 8t squared.
4 minus
18 squared.
18.
8, like 8.
Okay.
T.
4 minus 8t squared. Is this correct?
Sorry, 16 squared.
16?
6.
Okay.
So 8.
Other students, do you agree or do you have different? Agree, thumbs up. If somebody down, just let me know. Another expression. Yes, correct. The derivative of s with respect to time, for some of you, just please review the calculus to how to find the derivative. The derivative of 4t is 4. The derivative of this one will be minus 2 multiplied by 3, t to the power of 3 minus 1. It is minus 6t squared. Now, if I substitute t1 into here, 4 minus 6 multiplied by 1 square, this will be minus 2 inch per second. Also, we can find the acceleration. Acceleration is the derivative of velocity with respect to time, or the derivative of the 4 minus 6t squared with respect to time. If you take the derivative, will be minus 12t, or minus 12 multiplied by 1. It is minus 12 inch per second squared. Any questions? For example, for similar problem, I can give you this velocity and ask you to find the s. Okay? Or I can give you acceleration, give you the initial position and initial velocity, and ask you to find the initial one. Yeah. Next question. How much is the initial velocity of this machine? Four. How much is the initial velocity of the machine? 4. It's correct. If you plug in t0 into this equation, you can find that the initial velocity of the machine is 4. How much is the initial position of the machine? How much? 0. If you plug in t into this equation, you can find initial position is 0, but when started, the machine has a velocity of the or speed of 4 inch per second. Those equations or those information, sometimes it is hidden in the problem. Okay? I will give you those equations in the exam or quiz. But for example, if you need those information, you have to look them into this equation. Sometimes this information are hidden in the problem. Okay. Any questions? That was easy one. The formula that we used in the previous, in this slide, we used some of the formula that they are not always for the rectilinear motion. You will see that this formula can be used for other type of the motion in this course too. Okay. However, for some specific kind of motions, also we can find some of the equations from this general equations. What type of kind of problem? For example, it's a ball. I drop this ball from this height. If I drop a ball from certain heights, how much is the acceleration of the ball? Just this one. If I hold it, released it, what type of acceleration applied to this one? Yes. What? Correct. And what is this one's called? Gravity or gravitational acceleration. Gravitational acceleration, we consider this one as a constant. Okay? We assume that the gravitational acceleration is constant. And for this type of the problem, that the acceleration is constant, for this problem, acceleration equal to g, the magnitude, equal to 9.81 meter per second squared. Now, this question comes to your mind that, for example, how long does it take that this ball, when I release and then reach to the ground, how long does it take? Or what is the velocity of the ball at the middle of this drop, or at the h/2 or middle height? To find those information, we can find just these are the equations. I already list them on the previous slide. This 3-1, they are always valid for any type of the motion. However, for a specific problem, look like this. When the acceleration is constant, we can find some equations. Again, just I will find one of them, then for other ones, I will show you the final equation. To find this from this equation, I just mentioned that the acceleration is constant. I call AC, constant acceleration. From this equation, when the acceleration is constant equal to derivative of velocity with respect, then derivative of velocity equal to AC dt. If I take the integral on the both sides of this equation, and at the time 0, it is v0, initial velocity. At the time t, it is v. Left-hand side, it will be v minus v0. Right-hand side, if we calculate, is ACT. Means that velocity will be v0 plus AC multiplied time. This is only one equation. For other ones also we can find. But for example, for this one, to find the velocity at this point, for example, it takes 1 second from here to the middle of this height. And initial velocity, because I dropped this ball, initial velocity is 0. Now, I can find the velocity at this point. How? The velocity will be v0, 0 plus AC is 9.81. It takes 1 second. Means that, for example, the velocity at this point is 9.81 meter per second. For example, or at any time. Now, For a constant acceleration, if this is for a special case, with a constant acceleration, we can find these three equations. This one I found from previous slide. Also, from this one, if you plug in velocity into this and find this integral, we can find this. And also, if you use the third equation, you can find this. You can see from this equation also, I can find the height of the drop. For example, I drop the ball. It takes 2 seconds. I want to know that how much is this height. Under a constant acceleration or constant gravitational acceleration, if I use this equation, from this equation I can find the position. From this equation you can see there is no time. Now from this equation to find h, s is h, s0 is 0. It is started just if I take the origin from here, S0 initial position 0, V0 I drop with initial velocity plus 1 over 2, AC is 9.81, T is 2 seconds, and for this one, if you calculate, it's 19.62 meter. Means that if you drop a ball and it takes 2 seconds, the height of the drop is 19.62 seconds. Got it? Also, from this one, if you have this velocity and this initial one is mostly 0. For example, also from this one, you can find the S. If I gave you V 19.62 into this equation, the S is given to you. And also, put into this equation, you can find the velocity, for example, at any point. These three equations, they are only valid when there's a constant acceleration. You cannot use those equations when the acceleration is changing with the time. For example, the flight of missile, launch vehicle, the flight of an airplane. The acceleration will be changed during the time. Acceleration of the jet turbine or motor. Okay. This, and this. Any question from this part? I will use these three equations in the next sessions that I will teach about the projectile motion. I will return back and use these three equations. Okay? Why? For that type of motion happens under a constant acceleration. I will use those equations later too. Any questions? No? No. Let me solve the problem. This problem that I will solve here for you, similar problem I will give you for the assignment or homework 1. Okay, you will see similar problem in the homework 1. Please read this problem. If you want to write it in 1 or 2 minutes. I will start to solve this problem. It's a long problem. Yes.
I just want to confirm my answer percentage.
There's some yes, Okay, let's solve this problem. There's a particle move on a straight line. It's a rectilinear motion. The velocity is given to you, 12 minus 3 t squared. When t is 1 second, it is located 10 meters to the left of the origin. Look, if this is an origin, S is the coordinate, particle started from somewhere in here, minus 10. Now it started at t equal 1 second, it is located 10 meters to the left of the origin. What we are looking for to find, we are looking for to find the acceleration at t 4 seconds. Also, what is the displacement? Means that it will be the difference between S10 minus S0. S is the position at 10 seconds, S is the position at 0 seconds. And also, what is the total distance? These are what I'm looking for this problem. Finding the acceleration is very easy. In my opinion, this is the easiest one that most of you, or all of you, can find acceleration. The challenging part is the two parts. First, find S, position equation. You will see that velocity is given to you, but S equation is not given to you. But something is given in the problem that you can find the position, is the velocity. And finally, S total. Also, there's some point or tip inside of this one that I will explain. Now, we will start with the easiest one to find the acceleration. Velocity, it is 12 minus 3 times square. Acceleration will be, how much is it? Does anybody calculate the acceleration? Yes. Correct. Acceleration is the derivative of velocity with respect to time. The derivative of this one with respect to time, 12 minus 3 times square with respect to time, it is minus 6t, or minus 6 multiplied by 4, it is minus 24 meter per second square. This is the easiest one. Now, how about the S? How can I find the S? Yes.
take the integral of the velocity.
Okay, that's good. To find the s, we know velocity is the derivative of s with respect to time. We have the velocity, or ds equal to v dt, or ds is equal, velocity is 12 minus 3 times square dt. If I take the integral on the both sides, please do not hack me. Just kidding. Their internet goes. Okay, now is to take this integral, but there's some tip on this. What? At the time, you will see that the only information I have at the time 1, the s is given to us. This is the information is given in the problem. Now, means that at the time -1, s is -10. This is the point, one of the points for this problem. Or at the time t, s is s. Or this integral, ds from -10 to s equal to 12 minus 3 times square dt from -1, oh sorry, I just mentioned -1. T, I need to use and find this integral. This integral will be s minus -10. This integral will be 12t minus 3t cubed divided by 3 from 1 to t. Left hand side will be s plus 10 equal to, this will be 12t minus t cubed, or this will be 12t minus t cubed minus, if I plug in 1 into this equation, it will be 12 minus 1. Or s plus 10 equal to 12t minus t cubed minus 11. Or I will write this one for this color, s is equal to 12t minus t cubed minus 21. Now, I found the s equation. Got it? Any questions? Now, when I have s, I can find the initial position of the particle. How much is the initial position of the particle? How much is it? Yes, minus 21. As it is 12t minus tq minus 21, initial position, or S0, will be 12 minus multiply 0 minus 0 cube minus 21. The initial position is 21 meter, minus 21 meter. Also, if you put S10, we need to find S at the 10 second. It's 12 multiplied by 10 minus 10 cube minus 21. It will be 120 minus 1,000 minus 21. If you calculate this one, it will be minus 901 meter. Now, I will draw the position of this particle during different times to see what's the kind of how this particle moves. Look, it's a rectilinear from the origin, started at t1 second. At t1 second, it is minus 10. This is t1 second. At t0 second, it is in here. And at t10 second, it is in here. Now you can see that this particle started to move from 0 second, move to the right, then go somewhere and return back to this position. Okay. Also, we can find t3, 2 second, 4 second, any of them to find how this particle moves. This particle started from here, go somewhere, then return back to this position. Now, means that this going somewhere, then return back to here. This is the track of this particle. Now, the next question will come up. When this one returns, how can I find this point? Why? To find this point, help us to find ST, total distance. You do not know how much is this distance. Okay? I want to find. To find this position, I need to find the time. Because already I have S. I need to find the time when this one returns. How can I find this one? This position is when the velocity is 0. Why? If you go to this direction, then you want to change your kind of movement to the another one. At the turning point, the velocity is 0. Means that at this point, turning point, velocity is 0. We have the velocity 12 minus 3 times cube, 3 times square. Velocity 0 means that 0 equal to 12 minus 3 times square. From this, we can find t is 2 seconds. at 2 seconds, t equal to 2, the velocity is 0. Also, if I put this t into s, I have the s equation. 12t minus t cubed minus 21. If I put s2 into this equation, 12 multiplied by 2 minus 8 minus 21. If you find this one, it is 24 minus 8 minus 21. This point, it is minus 5 meters. Means that this point, it is minus 5. Now, why I need this one? Why I want to find the total distance. Total distance is this distance plus this distance. Any questions? No questions. Okay. Now, look, from minus 21 to the minus 5, this one, it's approximately, just if you calculate it, it is 16. And also, this point here to here is 16. And from this point to this point, it is 901 minus 5. Means that I can find the total distance is summation of 16 plus 905 minus 5. Now, total distance will be, again, here is the origin. This is minus 905. This is minus 5, starting from minus 21. And here to here is 16. Here to here is 905, 901 minus 5. ST will be 16 plus 901 minus 5. If we calculate this one, it will be 912 meters. Now, delta S is S10 minus S0. If we calculate, it will be minus 880 meters. Also, we can find wave speed average, that is ST minus over the delta T. ST, it is 912 divided by 10. This will be 91.2 meter per second. This and this. I think that the second question and third question in your homework is similar to this problem. Any questions? Any question, guys? No? Okay. Now, announcements. I already just announced the schedule. I will upload homework after the class time. The due date for the homework will be next Thursday, 1 week, at 8 a.m. After this time, it will be just you cannot see the submission. It will be disappearing the blackboard. Please submit your answers before the due date. Okay? There are four questions, and all of them related to the course. Nothing, just I solved most of them, just you will see. Let me know if you have any questions. Then, next week, wait, please, wait. If I close my laptop, means that class is over, okay? I haven't closed it yet. Next week, it's, I think that 122, am I correct? It's a Martin Luther King, and the class, we do not have class on next Monday, okay? This university will be closed. Next Thursday, just let me just see the times. On next Monday is 19, is 22, sorry. Next Monday is 19, and we do not have class, is Martin Luther King. And also, next Thursday, I'm in conference, and we do not have class, but I upload the recording of the class, and please watch the recording. Why? I put some class homework. If you do not watch it, you'll miss the class homework. And this class homework is a part of the class. And also, I ask you similar to this. I ask just put your review answers. Just you need to scan it, answer it, and I will upload it on Thursday on the class. But for the next class, we will have quiz. We will have quiz. And what is this quiz? Exactly this content. And also the questions are solved. And similar to the homework I just did. And after the Thursday, I will upload the solution for the homework. You can access the solution for the homework. Then you can practice for the quiz. Quiz will be one question. You can bring your own calculator. Okay, you can use your notes, no computer, no just internet anywhere, but you can use your note or my note. I will upload my note also in this. Got it? Anything else? Okay, thank you for coming to class. Have a wonderful weekend.
Thank you.
Thank you.
So much fun.
Professor,
Yes,
what is the conference you're going to for?
I'm going to a conference IMEC. It's a experimental mechanics in California. You can see 10 companies. Just search it IMEC. And it's usually available to this time. Within the spring time.
Okay. And mostly it's experimental methods and migration. Now, what I want to mention is the project that we will do, one of the options just for the next year. Next year conference will be, they already put this schedule. It was for long. Okay. This is, I saw somewhere. Yeah, yeah, it's in Florida. Yeah, another month. Or next, one of the things that I'm looking for is a kind of is any Congress. Let me see that in 2026. Where is that looking? Clinical science. Look, this this is my target also that we can submit the kind of abstract in March 10th. That this conference, let me see where it will be in Canada. Okay. And we will submit the conference in here. Okay. That's this one is the good one, especially it's free for undergrads. The registration. It's free and might be available when it's attendance. When they're studying, they can get the course or that fine. It depends. However, these are the conferences. This one is I had before students that just search it in here, you will see some of the information. Previous times, kind of for undergrad. It was a very good one. It's a conference. More than 2,000.
Yeah.
It's larger than
Yeah.
the conference.
Yeah.
Congress is larger than the conference because every major is that's one that I will go a specific major on. Okay. Well, let's work on this one with the optimization. So I use this very
Okay. So when are you thinking of like getting started?
I want to send I'm preparing the proposal and one next week I will send you this information. Or you can start your optimization. And that's
Yeah.
you already have set.
Yes, I've been going through the some of the tutorials and the courses in to like
I know
make sure I know how to
you can
use it.
go to YouTube.
Yeah.
Okay. For example, let me